Hello everyone, my name is Andrew. Today we continue learning Python, and today we'll talk about solid principles in Python. So let's start. Those principles are really important because they allow you to write better code. And there are 5 of them, and in total they're called solid. So the first principle, I talked about it before, is single responsibility principle. And that principle basically tells you that your class, your method, or your function should have one aim in their life. So here we have a class called calculator. That class is gonna calculate or evaluate some math problems. And we have sum, we can have divide or something like that, that accepts a, b as parameters and returns a divided by b. And also we have save function that saves our results to the database. So print saved to db. And why is it bad? Because right now our class calculator has 2 purposes in its life. The first one is to calculate our problems, and the second one is to save the results to the database. So the thing is that if we're going to change something inside of the database, so the way our data is stored, the way our data is saved, managed, and so on, or if we're going to change something inside of the math problems themselves, so for example, I need to somehow change my calculation method. So I need from that sum, I need to change it to sum like that. AB. So if we're going to change the code, or if we're going to work with our code, our class calculator is going to have 2 purposes in its life. And we may mess up some things because we change a class that has 2 purposes in its life. So if I'm going to change something in the calculation methods, I can mess up something in the data layer. If I'm going to change something inside of that save function, I can mess up something which is related to divide or some methods in my calculator class. And that is why each class and each method should have only one purpose in its life, or some people say that there should be only one reason to change your class. And in our case, the purpose of class calculator should be to calculate the math problems. It should not be the purpose like a very concrete purpose, like get the sum of 2 variables. No, it should be something more abstract, like calculate math problems, do something with the database, answer user requests, or something like that. So how do we apply single responsibility principle with that class? Is we basically say calculator is going to count our problems, but calculator saver class is going to save the results, just like that. So now we have 2 classes, which is calculator saver and calculator. That one is responsible for math problems, and that one is responsible for the data layer. That is better because now if I want to change something in the data layer, I'm only going to touch my calculator saver class. And I'm sure that calculator is not going to change its behavior. That's how it works. Also, if you're talking about functions, you may have a function, for example, save and update, something like that. And the same principle should apply to functions and to methods and to all the other things in programming. So you only have one purpose. Because if your function has and or in it, that means that most probably, you're going to have 2 separate aims for your method or for your function. So always think about that. If you're going to have save or update, or get client data and save data, probably it's not the best way to describe your function, and maybe you should split it to 2 methods. So always choose what's best. But remember that your method, function, or class should only have one purpose or one reason to change it during its lifetime. So that's how it works. The second principle is called open-close principle. And it basically tells us that our classes should be available for modification, or should be closed for modification, but should be available for not modification. I can't remember the word. All right, let me just show it to you because you'll understand what I mean. So we have class discount here, and discount gets the discounts for our user. So we have our user type as a string, and we're saying that if user type is normal, our discount is 20%. If user type is VIP, our discount is 50%. If our user type is going to be something like super VIP, then our discount is going to be 90%. And we may add that thing to our class. But that is modification, because we modify discount class. We modify it. But what's better is that if we apply open close principle and we close our classes for modification, but we allow to extend them. What do I mean by that? Instead of discount with one getDiscount function, what we can do is copy all of that, put pass here, and we're not probably going to need user type in that case. And what I'm going to do here is raise not implemented error. So not implemented error in Python basically tells you that your function is not implemented. You should implement it in the classes that inherit that class. And what I'm going to do after that is use class normal discount, just like that. It's going to inherit from discount, and we're going to have getDiscount function here. And look what I'm doing here. Instead of using ifs, I'm just going to create 3 separate classes. So normal discount, then VIP discount, that uses the same method called getDiscount, but now returns 50%. Just like that. And the last one is going to be called, all right, let me remove it, and the last one is going to be called super VIP or VIP discount. Discount, just like that. Define getDiscount as well, and return 90 here. So now we extend our classes, but we don't modify them. And why is it better? First of all, it's better because now we have a literal structure. We don't just use ifs. And using that if something returns something, if something returns something is not always the best case. Because sometimes you're going to have not one line of logic, just not return, but you're going to have 3, 4, or even 10, 20 lines of complicated logic depending on your, in our case, on our user account, on our user type. And why is it better? Because if we modify that discount class, it's going to be really hard for us in the future to maintain that code, and it's going to be really hard for us in the future to improve the behavior. Because if we have 3 separate classes and we extend them instead of modifying the base class, it's going to be much easier. Just trust me, it's going to be much easier to work with any differences in our code in the future. So if you're going to have to change something, it's going to be easier than to change it when you extend your classes, then to change it with a simple discount that just modifies the base class. Aside from that, if you're going to add some complicated logic, it's going to be much easier as well. So it's just easier to develop the things when you have extension, not modification. That's how open close principle works. So always do it like that. Build your classes so you can extend them. Always think about that. Don't build a class so you can modify it in the future. Build a class that you can extend with the classes that will inherit from it. Kind of like that. All right, but be sure not to create a lot of classes, because that's going to be useful and useless, because you can still use ifs. So ifs are not bad. I'm just saying that you need to write your classes in such way that you extend them, not modify them. Okay. Then we have Liskov Substitution principle. So Barbara Liskov Substitution principle. What is that? It basically tells you that classes that inherit from, child classes that inherit from the parent class should always carry the same behavior and should be used in the same way as their parent classes. So here we have 2 classes, basic identification and password identification. Basic identification is, some kind of basic identification that just returns our input. And password identification in function getPassword just prints our password. And of course it inherits from basic identification. So what is the problem with that code? Imagine that we have a function called auth user, and the auth method is in here. We use it as basic identification, and what we can do here, auth method dot get password. So password equals auth method dot get password. If you have the code that you're seeing right now, there is a problem. Both of those methods carry different behaviors. So getPassword and getPassword in password identification and getPassword in basic identification carry different behaviors. And it's going to be really hard for us to change them in the code in the future. Because imagine that we want to add another class called DNA authentication, for example. Authentication, just like that. It's going to inherit from basic authentication and somehow it's going to return our DNA. I don't know. Right now, we can't interchange those classes easily, because if I say, I want to use DNA authentication, it's alright, so my password is going to be returned here. But if I'm going to use my password authentication, it's not alright, because we just print our password in getPassword function. So whenever I talk about Liskov substitution principle, I think of the idea that you need to just change your classes on the fly. You can change your classes whenever you want, and they will still work. Of course, the behavior may be different. So for DNA authentication, you may run some sensors that will, get your fingerprints or something like that. For password authentication, you may just write your password using your keyboard. For basic authentication, you could do something else. But the idea, the aim, and the result of the function should always be the same or very, very similar, because we want to interchange those classes in the future. You don't know how many methods of authentication or other things you're going to have in your code. And you need to build your classes in such a way that you can quickly interchange them to others. So in our case, if in password authentication we return our password as a string, what we can do now is basically DNA authentication, we can use it, no problem. Password authentication, we can use it, no problem. Basic authentication, no problem as well. Because our getPassword method carries the same behavior as DNA and password authentication do. And that's how it works. So basically, once again, it tells you about the idea that your classes should be easily interchangeable between each other. Kind of like that. The fourth principle is interface segregation principle. So what is that? Here I have a class called CRUD_service. It has save function, get function, update function, and delete function. As you can see, none of them are implemented. And once again, in Python, we have raise not implemented error. It basically means that that function should be implemented in the children of that class. And in some languages, if you come from C#, Java, C++ doesn't have those, C doesn't have them neither. So if you come from C# or Java or any other C-like language, then you're probably familiar with interfaces. So interface. Or if you worked with Solidity, for example. Interface is basically a skeleton for your class. So it tells you what you should do, but it doesn't tell you how. In our case, CRUD_service can be considered an interface. And in Python, those are called ABC or abstract-based classes. And the ABC is basically a class that just shows you what is the functions that you need to implement. What are their parameters, what are their names, and what do they return. In our case, CRUD_service says that we should implement save, get, update, and delete. And for interface segregation principle, in our case, we can call it ABC segregation principle. It's going to be really important, because here we have our user service that inherits or defines or defines CRUD_service class. It basically says that user service is CRUD_service, and we need to implement save, get, update, and delete functions inside of it. So as you can see, we do it, there is no behavior, but we use prints, so those are implemented, and we can save our users, get our users, update our users, and delete our users. So I think all of you know about CRUD, a very simple idea in IT. You can create, read, update, and delete your data. And then we have order service, but there is a big problem with our order service. Save, get, and update are alright. However, delete function cannot be invoked because we can't delete our orders for some reason. So it's our business rule. We can't delete our orders in any case. And that is why we can't just leave the function delete as it is, because it's gonna bring an error. So what I'm doing here is I'm saying, if someone calls delete from the order service, just raise a value error. No delete can be made. And why is that a problem? Well, there are a lot of problems. The first problem is that as a programmer, I do not expect my delete function to just simply raise an error. Of course, if that error is not expected, so I can't call delete at all. And interface segregation principle basically tells you that it's better to have different interfaces, in our cases ABC classes or abstract-based classes, that help you to build the behaviors that you really want. In our case, we have one big general CRUD service ABC class. But what if instead of just one big general ABC, we can build different interfaces for our project. So instead of CRUD service, what I'm gonna do is I'm gonna create a new class called CRU service. And if you have something like that in your own project, then I would not recommend you using CRU, because everybody knows about CRUD, and it's better to write CRUD like that. So let me just quickly rename my class CRUD like that. But CRU is not known to anyone, so be sure to name your name your classes, name your abstract base classes, interfaces accordingly. So CRU is not known to anyone, so maybe create, read, update. But I'm just gonna write CRU so you understand the idea. CRU function is the function that is gonna have save, get, and update method inside of it. And then CRUD service is gonna inherit from that CRU service. And also I need to put ABC in here. So let me just import it from ABC, import ABC, abstract base class. That thing basically shows Python that is really an abstract base class. I not usually use it, but you can use it, there is no problem with that. Or you can just raise not implemented error. And CRUD service now is CRU service, so it has save, get, and update, but it also has delete inside of it. And we created two separate, or we segregated one big interface into two separate abstract base classes. And I'm going to interchange interface and abstract base classes in Python, but you need to know that in that language you don't have interfaces in their pure form. And you almost always will use abstract based classes. But you need to know that in other languages I'm talking about interfaces, so I'm going to interchange the terms just like that. So we have CRUD service and CRU service. What I'm going to do now is in user service, I'm going to inherit from CRUD service, because user service needs save, get, update, and delete. But in order service, I'm going to get CRU service as my parent class. And here I'm going to delete my delete method, because I don't need it. I'm saying that order service is CRU service. It should not have delete, and no one will call that delete in the code somewhere else. And now we segregated our big interface into separate ABC classes, and that is always better. You may ask, all right, what if we need a class that only has save and get, or save and update, or get and update? No problem. You just copy the function, then you say class, create service, just like that. Because it's not a class in its normal sense, it's an abstract based class. It basically shows you what you need to do, but it doesn't tell you how. And what you can do is compose those classes together. And lots of languages do that. So if you look in C# code, then you're going to find millions of interfaces composed together. So that's, they all use it because it's interface segregation principle. It's really, really important. So always have separate interfaces for separate tasks. Don't have one general interface for your whole code or for some general idea. Try to make it as segregated as possible, of course to the normal extent. And the last thing is dependency inversion principle. And it's really easy to understand. So, as I said, we have base classes, so abstractions, and we have their definitions. In our case, what we can have here is class base user that has get user info inside of it, and it raises not implemented error. And what we can do is have user inherit from base user. Now, run program is a function that accepts user object and gets the information of our user. So it's our application code. And dependency inversion principle basically tells you that you should not rely on details, you should rely on abstractions. Instead of using user as the base type here, we're going to use base user, because base user is an abstraction for that user class. Why is that? Why do we need to rely on abstractions? Well, if you think about it, it's just easier. You don't rely on the definition so you don't rely on the idea that you need to do something in such way and only that way. Because maybe we're going to have something like VIP user that inherits from base user as well. And here we're going to have get user info that returns VIP info. If I rely on user, then I'm basically saying that the only thing that I can provide in my function is user. But if I rely on base user, I'm saying that I'm going to provide an abstraction. And it's almost always better, well, it's always better to rely on abstractions, because now I can either provide VIP user or user, because both of them define that ABC, so abstract base class. Also, if you think about normal project, you don't rely on how your operating system works. You rely on abstractions, on how everything is abstracted from other classes and all that stuff. So dependency inversion principle basically means rely on abstractions, not their definition. And that's basically it. So if I delete all of that and delete all of that, we get solid. And solid is a really important concept. If you have any questions, ask them down in the comments. My name is Andrew. Thank you for watching. Subscribe to my channel, leave a like, leave a comment, and bye-bye.